Welcome to PCB Piezotronics, a world-class manufacturer of sensor technologies for product testing and condition monitoring, including accelerometers, pressure sensors, acoustic products, force sensors, impact hammers, and more. All built with a dedication of unmatched total customer satisfaction. For over 50 years, from humble beginnings in a basement outside Buffalo, New York, PCB has grown with facilities across the country and throughout the world. The backbone of PCB's operation is a system of vertical integration. We control the components, we control the process, we control the quality. PCB's commitment to vertical integration begins with our private use machining center, a standalone 52,000 square foot facility adjacent to our main assembly plant. Operating 24 hours a day, 6 days a week, employing over 180 people, producing 180,000 parts per month to meet customer demand.
Our machine shop showcases the investment PCB has made into all phases of vertical integration, allowing PCB to control delivery and quality to you, our customers.
PCB has dedicated machines and operators to form a cohesive work center focused on new product development and technology, decreasing the time to market of new products. Our experienced, versatile machinists can both program and machine a wide range of new parts on various machine technologies and provide valuable intel to our engineering team to bolster product designs. The first of many work centers is comprised of multi-spindle Swiss production machines. Feature-based part families on each machine are produced utilizing up to 11-axis, 2-spindle, simultaneous machining. Micro-machining capability can produce flatness up to 20 millionths of an inch.
Production flexibility affords for batch sizes to range from 10 pieces up to 10,000 piece runs.
Alloys are fed into the machine via integral bar feeders, then actioned by the dual spindles located inside the machine. Unique coolants are utilized to reduce heat transfer, promoting longer tool life and sharper material cuts. Our continuous improvement efforts drive focus on setup reduction and part quality. EDM, or electro-discharge machining, is a unique process using an electrified, deionized water bath rather than cutting tools. A thin string of brass wire is used as a routing agent, initially fed into pre-drilled holes in the sheet metal. Stacks of sheet metal are placed in the machine, cutting multiple parts per turn.
EDM technology is deployed when required geometry is not practical or possible for traditional cutting style machines. This technology affords for very unique one-cut operations.
Once set up, machines operate independent of operator control, capable of production runs of up to 1,500 parts. PCB's Milling Work Center focuses on parts with very tight tolerances, which can be witnessed in our triaxial and teardrop sensor line.
These machines utilize acute capabilities to hold the very tight tolerance requirements of sensors used in aerospace applications.
5-axis machining utilizes both a stationary and active XY table, bringing tools to parts and parts to tools. Cutting at high speed, with manufacturing cycle times of approximately 10 minutes or less per piece.
Early adoption of lean manufacturing principles, such as SMED, or single-minute exchange of dies, has allowed PCB to maximize part-to-part changeover, increasing efficiencies and utilization of not only our machines, but also of our highly skilled machinists.
A machinist can run multiple machines at once while parts are in process. PCB's continuous investment in machining technology has allowed us to find cutting-edge machinery now capable of performing traditional secondary operations such as lapping and deburring on these machines. Complementary milling is performed at our FMS Machining Center, a unique pallet-based system that delivers fixtures to both operator and machine. This work center utilizes smart programming, capable of having hundreds of work orders in progress at a given time. Knowing where available capacity exists for optimal utilization.
Manual lathes are a core competency of any machine shop.
They are used for secondary operations in smaller production volumes, including development work, to avoid full programming of the larger machines. Operators control all facets of the machining process, including toolings, cuts, and speed. Lapping, another secondary operation, is performed post-machining to achieve desired surface finish or flatness on many components.
Proper surface finish is vital to sensor construction, affording for parallelism of stacked components, minimizing unwanted output such as transverse sensitivity.
Many machines do not have capability to produce parts to desired surface finish, making lapping an important process. Deburring removes fine burrs and smooths rough edges, which most machines are not capable of. Highly trained technicians review individual parts under microscopic inspection, utilizing dental-like equipment to perform these vital operations.
Removing burrs and smoothing edges is important during sensor assembly, as a burr can dislodge, leading to sensor defects such as no turn-on or intermittent output.
Miraclean is a necessary quality operation for all parts produced in our machine shop to clean and remove machining oil residue left over post-machining, ensuring no contamination can permeate during sensor assembly.
Such contamination can lead to insulation resistance, among other issues that affect sensor performance.
This automated process utilizes a carrier system, moving batches of parts from one tank to another, with each tank utilizing specialized cleaning fluids to remove the latent machining oils. This work cell utilizes several different machining technologies to produce larger size parts, traditionally serving our industrial and force sensor customers.
PCB has reserved capacity within this work cell to respond to customers' urgent delivery needs, with machines sitting idle until critical demand is required.
This workforce is highly trained to set up a machine and quickly produce machine parts for assembly.
PCB's machine shop includes additional capabilities such as injection molding to create components like thermal resistive boots, mounting accessories, and tips used for force hammer measurements.
Precision metal fabrication affords for shearing, punching, sanding, forming, and insert installation of the frames for our signal conditioners assembled in-house.
Together, these unique work cells form a cohesive system of vertical integration, producing the variety of parts needed for assembly of sensors in the main production facility, while controlling part quality and optimizing lead times. PCB's vertical integration continues in our new 30,000 square foot crystals facility.
Crystals are the heart of any piezoelectric sensor.
PCB produces both quartz and ceramic crystals for use in our various sensor technologies. Quartz crystals are naturally occurring and are harvested by PCB's expert supply base. Quartz stones are then processed into finished crystals by PCB's skilled workforce. Unlike quartz, ceramic crystals are man-made. Raw materials are processed in-house and then machined with diamond cutting tools to form the final shape used in our sensors. Final products are tested for polarity and/or output characteristics before being used in our sensor assemblies. PCB's next dedicated facility is our connector manufacturing center, producing nearly 30 different connector types for the wide variety of PCB sensors. Hermetic connector assemblies begins with contact pins being inserted into the connector back shell. Then the cavity is filled with glass beads, which are then taken from room temperature and heated in the presence of uniquely formulated gas mixtures.
This allows the glass beads to expand and contract, forming a hermetic seal on each side of the contact pin.
Common connectors manufactured are 2-pin military style, used heavily in our industrial sensors, 4-pin and mini 4-pin connectors, utilized in our triaxial accelerometers, among others.
This manufacturing is unique to our industry, allowing PCB to further control both elements of delivery and quality of our products.
Microelectronics assembly is the backbone of our patented ICP technology.
ICP, which stands for Integrated Circuit Piezoelectric, uses an electronic circuit to convert the charge output produced by a crystal under stress into a proportional voltage output.
Individual components can be placed manually onto a pre-populated substrate by highly skilled technicians, or can be placed using high-speed machinery, capable of not only placement, but also inspection simultaneously on machinery found in a very large substrate assembly house. The evolution of circuitry has produced a significant reduction in size, with more efficient componentry, translating into improved sensor design and performance.
PCB remains at the forefront of this technology, constantly evaluating and improving designs, ensuring we're providing the most cutting-edge products.
With the core components of our sensors completed, the assembly process begins inside our main production facility. Products, primarily assembled under microscopes, are handcrafted by our over 500 technician workforce operating in our manufacturing centers. Each technician begins their journey spending the first 2 to 3 months of on-the-job training, learning key facets of assembly such as soldering, spot welding, epoxying, cleaning principles, and more. As technicians graduate from the training program, they are introduced into production work centers with mentorship by senior-level technicians, all supported by an in-depth audit program. PCB continues to invest in our assembly efforts, most recently adding ISO Class 7 and 8 clean rooms, affording for pressure and force sensor production to be formed under more rigorous environmental controls, improving product quality and performance.
These ISO Class 7 and 8 clean rooms utilize HEPA filtration systems to maintain air cleanliness levels of 10,000 and 100,000 parts per million respectively.
Additional laminar flow workstations create a 0 parts per million surrounding while products are being assembled, ensuring the highest level of integrity and accuracy. Laser welding, a strategic on-premise process, creates a hermetic seal to the atmosphere.
This allows the sensor to operate without contamination, loss of insulation resistance, and other negative performance effects.
Our process fuses components together in lieu of adding any filler material, initially by tack welding the components, effectively holding them in place, followed by high-speed circumference welding, which then seals the weld. Our skilled welders observe the actual weld under magnification while in process, and further ensure a quality weld with a gross leak test performed on all of our welds.
Our team works across 2 shifts, producing thousands of welds per shift.
PCB's welding capabilities allow for the smallest weld joints all the way up to large industrial-style sensors, requiring deeper weld penetration under longer pulse widths. PCB sensors and signal conditioners go through rigorous testing to ensure they meet precise specifications before shipment to our customers.
PCB is an AS9100 facility with ISO 9001 and 17025 accreditations, with calibration equipment certified by A2LA.
PCB has dedicated equipment and facilities for calibration of vibration sensors, pressure sensors, force sensors, and electronics. PCB also offers calibration services for other manufacturers. In the etching department, using light penetration, sensor housings are etched with logos, model and serial numbers, and other important information.
We also offer private labeling complete with customer logo, certification detail, and barcode capability.
Final inspection is the last step in the journey of all PCB products. Our technicians not only ensure the cleanliness of the products, but more importantly perform final tests, such as turn-on testing and continuity checks of cables. Required accessories are added before finally packaging and preparing for shipment to you, our customers. PCB Piezotronics. From basement beginnings to world-class sensing technologies. PCB is driven by a unique system of vertical integration, end-to-end control of the components and processes that make our sensors, and a dedication to unmatched total customer satisfaction.
We look forward to another 50 years of providing sensors and systems for your product testing and condition monitoring needs.